4.1 triangles and angles. All right, so the first one, it's like a matching, kind of like when you like do your vocab quizzes. It has like almost like a definition and then a word, but they're going to give us an example of either 3 side lengths or 3 angles of a triangle, and then we're saying what kind of a triangle it would be. I'm going to just have us do it without like actually matching, but I'll tell you what letter it is in case you are going back to look later. So number 10, they give us side lengths of 2 centimeters, 3 centimeters, and 4 centimeters. So what kind of a triangle has no side lengths that are congruent to each other?
Scalene.
Yep, scalene. And if you're so curious, that's letter B. 12, side lengths, 4 centimeters, 4 centimeters, and 4 centimeters. So what kind of a triangle has all the sides are the same?
Equilateral.
Yep, equilateral. And that would be option A. And then 14, angle measures. 30 degrees, 60 degrees, and 90 degrees. What kind of triangle would have those angle measures?
Right.
Yep, a right triangle. If any of them have a 90-degree angle, it automatically is a right triangle, and that's option F. All right, the next problems give you a picture of a triangle, and they want you to classify it based on its angles and side lengths, if applicable. So, 16, have a triangle. That looks like that. So I've, because I know it's small, 2 angles are 59 degrees and 1 is 62. And then I have 2 sides that are listed as congruent because they have these little lines on them. So we need to classify this based on its angles and based on its side lengths. So any idea what kind of a classification that would be?
It's like isosceles.
Isosceles for the sides, and what else?
Acute.
Yep, acute. All the angles are less than 90 degrees, so it's acute. Isosceles. $18. Whoa, I made that triangle really large.
Yo, bro, that's so straight.
All right, so they only give us one angle on this one. They tell us that angle M is 120 degrees. So what has to be true about this triangle then?
Obtuse.
It's got to be obtuse, and what else?
Scalene.
Why? You're right. I just want to know why.
None of the angles match. They don't look.
Scalene deals with sides.
No sides match up.
Okay, yeah. They don't give us, you can't just say they don't look like they're the same, because that's not accurate. They did not put anything to show us that any of the sides are congruent. So we have to assume then that it is scalene. $20. All right, so we have triangle here. We've got two angles given to us. T and U are both 42 degrees, and then they show us that we have two congruent sides. So, what do I know about this one?
It's a cube. Isosceles.
Okay, it is isosceles, but what else? What do I know? Huh? Nope. What do I know about the angles inside of a triangle?
That you have to have 80 degrees.
They equal 180. So I don't know what this angle is, so I need to find it. So 180 minus 42 minus 42 is equal to what? 96. So now what kind of triangle is this? Obtuse. So it's an obtuse isosceles triangle. All right, the next problems are always, sometimes, or never. So there's going to be a blank and you're filling it in with the word always, sometimes, or never. So 22. An isosceles triangle, and you do need to write the statement out, but if you want to use abbreviations, like I'm going to draw a little triangle instead of writing the word triangle, is blank an equilateral triangle. So an isosceles triangle is always, sometimes, or never an equilateral triangle.
Never.
Sometimes. Isosceles has to have two congruent sides. It could also have a third one, but that's not necessarily true. 24. An interior angle of a triangle and one of its adjacent exterior angles are blank supplementary. So in the blank, always, sometimes, or never.
Sometimes.
Always, because they make a linear pair. (26) A triangle, blank, always, sometimes, or never, has a right angle and an obtuse angle. Which one are you going with? You just gave me two.
Never.
Okay, so why? Why?
Well, let's see.
What's true about a right angle?
90 degrees.
What's true about an obtuse angle?
It's more than 90.
It's greater than 90, and a triangle has three angles, so if I have 90 and a number bigger than 90, that's bigger than 180. So that automatically is a problem, so this has to be never. So when you're doing these, as my mom would always say, the always, sometimes, or never problems are always, sometimes, or never confusing. So make sure that you pay attention and think about a sample of, okay, well, if I've chosen an angle that meets this, does this meet the requirements for it to be a triangle? Okay, like plug in or set it up and see, would this make sense when you're answering the questions? All right, now we're going to get into a few where we actually have to do a little bit of math, but nothing too crazy here. We're jumping down to 32. So these say to find the measure of the numbered angle. So basically they're giving you some of the angle values, and then some of them they're putting like a 1, 2, 3, etc. in there, and you're solving for what those angles are. So this one is kind of it's like a double triangle here. Kind of looks like a funny bow tie. So I'm going to put the markings on here that they give you. Oh, actually drew this side of this one wrong. It won't really matter, but... This one's supposed to look more like this. Okay. All right, so I need to solve for the measure of angle 1, 2, and 3. So let's just start in order. How would I go about finding the measure of angle 1?
You can add the 90 and the 40.
And then do what? Yep, do 180 minus 90 minus 40. And when I do that, what do I get? So angle 1 is 50 degrees. Angle 2, what's that one?
40 degrees.
Why?
Vertical angles partially.
Yep, they're vertical angles, so they have to be congruent. And then once I know angle 2, I can now find angle 3. How do I find angle 3?
5 plus 40 equals 135 minus 180.
180 minus.
Oh, I know what you're saying. Yeah. 180 minus 95 minus 40, which would give us 45. So you can either add up the two known angles and then subtract that from 180, or you can just do 180 minus that, but like you would have gotten to the same answer. So 50 degrees, 40 degrees, and 45 degrees. Solve those three angles. Questions on that one?
Oh, that's not too hard.
No, they're not too bad. 34. All right, these ones say the variable expressions represent the angle measures of a triangle. Find the measures of each angle, then classify the triangle by its angle. So these ones are, we have to solve for x first, but that's not your answer. We're finding the actual angle values, and then based on that, we're going to classify the type of triangle. So the measure of angle A is x degrees. The measure of angle B is 2x degrees, and the measure of angle C is 2x plus 15 degrees. All right, so if I know this makes a triangle, what do I know has to be true about these three angles? They have to add up to be 180. So x plus 2x plus 2x plus 15 equals 180. Combine like terms, so I have 5x plus 15 equals 180. Subtract 15, 5x is equal to 165. And then divide by 5, x is equal to 33. So this value is now going to get plugged in up here for x in each of these equations. Okay?
There's no game today, right? Come on.
Right. All right, so I'm going to take this and plug this in up here. So that means the measure of angle A is equal to 33 degrees because it was just x. The measure of angle B is going to be 2 times 33, which means it is 66 degrees. And then down here, measure of angle C is 2 times 33 plus 15.
81.
So I've got 81 degrees. And then you can always check by adding these numbers back together and making sure they equal 180 if you're not sure if you did your math right or if you think you might have done something wrong. So now, based on that information, I have an angle that's 33, one that's 66, and one that's 81. What type of triangle is this?
Yeah, obtuse.
What does obtuse mean?
Bigger than 90.
wait.
Bigger than 90? Are any of those angles bigger than 90?
Cube.
So acute scalene.
They didn't ask us anything about other than the angles. It's acute. So you had to find each of the angles, and then you had to classify it by its angles. Now, yes, you would be right. It is scalene. However, that's not what it asks us for.
Smaller than 90?
Yes. Anything less than 90 is acute. Huh? How do I what?
No.
Okay. All right, 38. They give us a picture again. You can just sit right there if you're done. I'm gonna draw this going in here because this is where this angle goes, but it's not gonna fit. All right, so that's what this picture looks like here. We've got a triangle, and then they've drawn an exterior angle off of that. So, using our exterior angles theorem, it says that the measure of angle 1, which is your exterior angle, is equal to the measure of A plus the measure of B, which are these two non-adjacent angles here. So, to do this, we set this up. Siri decided she wanted to state the exterior angle theorem on my watch. All right, so we have 38 plus 7x plus 1 equals 10x plus 9. So, combine like terms over here. I've got 7x plus 39 equals 10x plus 9. Now, to not have negatives, not that I can't because it's going to work out, but I'm going to move the 7x to the right and the 9 over here to the left. So when I subtract the 9 from over here, I get 30 on this side. Subtract the 7x, then I would get 3x. I have 30 is equal to 3x. Divide by 3, x is equal to 10. Now, again, that's not what they asked me for. They asked me to find the measure of the exterior angle. So I need to take this number and I need to plug it in to x on my exterior angle. So I have 10 times 10 plus 9. What does that equal to? 109 degrees. So the exterior angle is 109 degrees. So really make sure you watch. Are you solving for x or are you solving for the angles?
Is it 205?
Hmm?
It's 205.
It's not. That clock's not right. All right, one proof. I'm doing the one that they give you nothing. You're going to be doing one that you fill in the blanks. 48. This one says write a 2-column proof of the corollary to the triangle sum theorem. So we're proving that there. Now, the corollary to the triangle sum theorem says the acute angles of a right triangle are complementary, and they tell us that, so the given from the theorem would be that triangle ABC, or we have triangle ABC with the measure of angle C being equal to 90 degrees, and that would have been from the picture that was given in that corollary. And we're trying to prove what this theorem says, that the measure of angle A plus the measure of angle B is equal to 90 degrees. So I'm going to set up my proof. All right, so what's always my first thing? Given. Now, this is just telling me it's triangle ABC just so that I know what it's classified as. My given part is really only this part right here. Not that you can't have the other part, but measure of angle C is equal to 90 degrees is my given. Now, the triangle that they had given you, well, it doesn't look like that because it's a right triangle. I'm just showing what it looks like for you. So that triangle would look like this. All right, so if I know that that's true, what do I also know about this triangle? Okay, but what do I know about like the angles? Because I'm ultimately trying to prove that the measure of A plus the measure of B is equal to 90. Yep, all of them added together equal 180, so I would go there next. So I would do the measure of A plus the measure of B plus the measure of C equals 180. And that is the triangle sum theorem. Now, I can use that because I'm trying to prove the corollary. All right, so then ideas on what would be my next thing? Knowing that my end result is supposed to be this. So compare that with what I have now. Ideas on what I need to do?
Subtract measure of one, measure of A and measure of B from 180.
Well, then I'm going to have 180 minus A minus B. So that's not going to help me. What's my given?
Measure of C equals 90 degrees.
Measure of C is 90, so why don't I?
You subtract it from 180.
Not yet.
Wait,
What?
measure of angle A plus measure of
Look,
angle B.
I haven't even plugged this in yet. I got to plug it in first.
It's the measure of angle A plus the measure of angle B plus 90 degrees equals 180.
Yes, and what would the reason for that be?
Substitution property.
Yep, measure of A plus the measure of B plus 90 equals 180, and that's by substitution. Now what?
You subtract 90 from 180.
Subtract 90, so I have the measure of A plus the measure of B is equal to 90, which is what I was trying to find, and I did that by subtraction. So a nice, easy proof. Now, the one that you're going to have is going to have you filling in blanks. So it's going to have the whole thing set up for you, so you'll need to copy it over and then fill in the blanks with what was missing. Questions on this one? All right, problems. You do have time to be working now. 11 through 25 odd. 31 through 39 odd. And then 43 and 47.